CAPS as a technology will help us figure out where the satellites are that are functioning and that are cooperating, right? There's a couple of key caveats. And so with that, we envision that you have sort of this peer-to-peer network, again, peers, so friends, that would be able to not just figure out where they are, but also potentially provide some of that, space traffic coordination functionality, ideally in more of an automated way. Again, trying to enable scale of operations without bottlenecks here on Earth. But these orbits also that we're talking about, and for Capstone and similar orbits, are also potentially really valuable for space situational awareness, not just around the moon, but about how things are coming from the moon to the Earth, or going to the Earth to the moon, or even back in more traditional orbits at the Earth. And so for us, we kind of think of Cislunar as kind of this high ground from which we can observe what's going on, keep track of things, but also provide sort of we call it an over-the-top resilience to some of these lower orbit systems. And so, a lot of times we talk about, cislunar or Earth orbit, kind of like they're different. But for us, we think like we're going to need that awareness that you referred to. We're also going to need, communications. We're going to need navigation. We're going to need all these capabilities, these requirements are going to exist through a continuum, right, from low Earth orbit all the way out past the moon. And so as we're thinking about these technologies, it's really not just about, hey, what's this applied to the moon, but really how does that apply to other orbits that we have to operate in from a commercial perspective or from a government perspective.